Hello everyone, and welcome to the effect of using Geogebra in geometric construction of grade 7 students, an article published in the International Journal of Science and Research ISSN 2319-7064, ResearchGate Impact Factor 0.28, SJIF in 2019 7.583, Volume 7, Issue 12 in December 2018. This e-presentation was prepared by Sana Shohaib, Assistant Professor at the Lebanese University, Muhammad Anouti, a PhD student at the St. Joseph University, USG, and Muhammad Akawi, Master's Degree in Educational Sciences, LIU, Lebanese International University. Now, before we begin, we have to know some of the facts about the Geogebra software. Geogebra is a dynamic mathematics software for all levels of education. It brings together geometry, as you can see here in the figure, algebra, graphics, statistics, and calculus in one easy-to-use package, as you can see here. It is rapidly expanding among millions of users located in just about every country. It has become the leading dynamic software that supports science, technology, engineering, and mathematics, also known as STEM. It provides innovation for the teaching and learning process worldwide. Now, the content of this e-presentation encompasses the background of the study, the theoretical framework, the research questions and hypotheses, the limitations and delimitations of the study, the research instruments, the results, and finally the recommendations. Background of the study. Mathematics is one of the most important subject materials for students to learn in schools. For that, their mathematical performance is critical in determining their scientific pathways and future careers, according to Barrow and Woods in 1987. In middle schools, mathematics starts to become a little more abstract for the students. According to Mamana in 1998, learners should know and distinguish the varieties of geometric shapes and their properties, as you can see here in the figure given. Due to many teachers relying on their traditional teaching methods, they instruct their students to use their imagination when they face an abstract idea or an ambiguous geometric concept. This type of instruction does not go well with many students for diverse reasons like math deficits or cognitive disabilities. Fortunately, in our modern era, technology has waved the path in front of students for a better understanding of some of the geometric concepts and constructions through many software that could be used in classroom and help improve their learning. Because of its rigid image, mathematics demands better teaching strategies that enable the students a better understanding of the subject core content, as you can see in the images given here. And because several studies show that using software like Geogebra can enhance, motivate, and engage students in classroom according to Panan 2014, then the impact of using Geogebra on students' learning, understanding, and construction of geometric concepts should be addressed and examined, because it might help improving their performance and even behavior toward mathematics. Theoretical framework. There are two important aspects for Piaget's constructivism theory: assimilation and accommodation. Assimilation is about adding and acquiring new information that do not contradict with our schema. Accommodation is realized when the newly acquired information contradicts with our knowledge. Constructivism is fully applied once the learner uses the Geogebra dynamic software because it supports the constructivist learning perspective and improves students' mental abilities. It can relieve students from imagining 2D and 3D dimension shapes, which in turn might improve their acquirement of geometric concepts and abilities in defining geometric shapes and rectifying geometric misconceptions. Thus, the use of Geogebra might enable students defining a geometric shape, verifying a geometric construction, and employing a geometric theorem. Research questions: what is the effect of Geogebra on students' performance of geometric constructions in grade 7? 2. To what extent does Geogebra improve students' attitude towards mathematics in grade 7? Research hypotheses: H01, there is no significant relation between Geogebra and students' performance of geometric constructions in grade 7. H11, there is a significant relation between Geogebra and students' performance of geometric constructions in grade 7. H02, there is no significant relation between Geogebra and students' attitude improvement towards mathematics in grade 7. H12, there is a significant relation between Geogebra and students' attitude improvement towards mathematics in grade 7. Limitations of the study: the researcher here have dealt with two limitations during the implementation of the study. First, the number of classes in grade 7. There was only 2 sections, which in turn reduced the scoping of a wider implementation. Second, the time given to implement the study and extract the results forbade the researcher from implementing it in other schools. Delimitations of the study: the staff in the school where the actual study was implemented, from deputies to the principal, helped the researchers creating one experimental group of 10 students and one control group of also 10 students, which consequently allowed teaching geometry differently in the designated classes for the benefit of the study. Research instruments: the pre and post tests and the survey were validated and modified by a mathematics coordinator and a professor in the field of higher math education. The pre-test was distributed to students in both sections, followed by the post-test to students in both sections, and the 5 point-likert scale survey to the students in the experimental group. Additionally, the Geogebra activities had the following objectives: 1. Discovering the property of the sum of the angles in any triangle. 2. Drawing an isosceles and equilateral triangles, as you can see in the images here. 3. Drawing other types of triangles like the scalene triangles. 4. Understanding the properties of some remarkable triangles. 5. Drawing quadrilaterals like the squares and the rectangles, as you can see in the images here. Results of the pre-test descriptive statistics have showed that both students in the control group and the experimental group had near mean averages in the pre-test. The control group grade average was 5.9750, while the experimental group mean in the pre-test was 5.85. The total number of students in the control group was 10, while the total number of students in the experimental group was also 10. Result of the post-test descriptive statistics has showed that students in the experimental group averaged better than those in the control group, as the students in the experimental group average was 6.95 over 10, while students in the control group average was 4.85. Additionally, results of the paired sample t-test have revealed a statistically significant difference in the scores, grades mean, between the control group average equals 4.85, standard deviation equal 3.07363, and the experimental group average 6.95 and standard deviation of 2.02004, condition T9 equal minus 2.383 at the P level of 0.041 less than 0.05. Additionally, results of the survey have revealed that 60% of students in the sample strongly agree with the fact that Geogebra helped them finding new ways to solve the problems. All students agree with being able to think creatively and critically when using Geogebra. 70% of students disagree with not exploring new geometric concepts using the Geogebra software. 60% of students agree with Geogebra helping them learning basic ideas better. 100% of students of the sample are willing to learn more geometric concepts through the same software. 60% of students do not find Geogebra hard to use. The geometric construction is more interesting to all students of the sample with the usage of the Geogebra dynamic software. 100% of students of the sample stated that geometric construction was boring prior to the Geogebra usage. Results also showed that Geogebra helped improving 40% of students of the sample in constructing geometric shapes. All students of the sample were able to construct geometric shapes systematically due to the visualization of Geogebra. Recommendations. Geogebra seems to be essential in supporting students in 2D geometry and maybe 3D space geometry according to future studies and researchers, where secondary students are forced to imagine the shapes. So, the researchers here highly recommend employing Geogebra in geometry and other diverse mathematical themes in all classes and levels. Thank you so much for your listening, and thank you for the International Journal of Science and Research.